Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we are going to be continuing on in our unit on quadratic inequalities. We're actually going to be starting outcome 9b here though, which is section 9.2 of your textbook. And all this outcome deals with is quadratic inequalities with only one variable. So before we were dealing with things like ax squared plus bx plus c is less than y, which would have had two variables, the x and the y. The only difference now is that they're not set equal to y, they're going to be set equal to 0. So we're only dealing with one variable, the x variable. And it can be in those following four forms: less than or equal, greater than or equal. A, B, and C are still going to be real numbers, and A cannot be 0, which means that it can be less than or equal to 0. And we're going to have a couple videos for this particular mini lesson. We're going to be dealing with solving these quadratic inequalities graphically or algebraically. And there's different methods to do it algebraically. And so we'll have one video for each method of solving. And just remember that our solution set can have no values, it can have one value, or it can have an infinite number of values. All right, let's get started. So in this lesson, we're going to be dealing with some word problems. So here we're doing example number 4, a word problem. And what we're asked to tackle here is this: if a baseball is thrown at an initial speed of 15 meters per second, from a height of 2 meters above the ground, the inequality negative 4.9t squared plus 15t plus 2 greater than 0 models the time, t in seconds, that the baseball's in flight. During what time interval is the baseball in flight? All right, so I'm just going to brainstorm here. I know that I'm going to have some kind of an inequality here, and I can tell you what my y-intercept is. My y-intercept is the point 0 and 2, and I know that because when you plug in 0 into your time, you're just left with 2. So it goes through this point, and that's about all I know for now, right? And yeah. So I think what my strategy for this is going to be is, let's start off by finding our x-intercepts. And so I'm looking at this, and there's no way in heck that I can factor that. I can't, unless I cheat with technology, and I'm not a cheater. I might use technology to check my work later, but I'm going to do this the way that you would have to do in class. And so I'm gonna have to plug it into this. Negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. And this is, of course, the quadratic formula. And I really don't see any way of going about this apart from using quadratic formula, because I'm not going to try completing the square, and I'm not going to try factoring that. So I'm going straight to this. So we have negative 15 plus or minus the square root of 15 squared minus 4 times a, which is negative 4.9, times c, which is 2. And this is all over 2a, so 2 times negative 4.9. Now I'm certainly using technology here. So let's deal with our radicand first. So we have 15 squared minus 4 times negative 4.9 times 2. All right, is 264. And what's the square root of that? 16.2542. All right, so we have negative 15 plus or minus 16.2542 over 2 times negative 4.9, which is negative 9.8. All right, let's try this out. So we have negative, let's not do that there. In the calculator, please. So we have negative 15 plus, I'm just going to copy this, plus that, and I got a few more digits there, that's fine, divided by negative 9.8. So negative 9.8. And let's see what this equals. All right, so my first x-intercept is negative 0.127983. And my second one is, I'm just going to copy this and change this to a negative sign. Okay, 3.18921. 3.18921, which we're going to round. Let's round both of these to just maybe 2 decimal places. So negative 0.13 and 3.19. All right. And now I kind of have a better idea of what this looks like. So it's like going to be just there. And then off to this one, which is 3.19 and 0. And this one like way there. I'm just going to kind of do that. And this is negative 0.13 and 0. Now my vertex, you know what? I don't care where my vertex is. And I know what you're probably thinking, that's not cool. I'm going to pretend it's there. The reason why I don't care about it is because it's just asking me for how long my baseball's in flight. So I don't really need to know that. All I know is it goes through here, through the y-intercept, it goes some distance in the air, and then it comes back down through my x-intercept there. And so when is it in flight? Well, this is actually even easier. Time can't be negative. So it starts off at there and there. So I'm just looking at that. So it's going to be from 0 seconds to where the height is 2 meters. And it's going to go some distance in the air, and then it's going to hit the ground at this x-intercept, which is 3.9 seconds later. And so that's when it's in flight. That's what I care about. And so now I can say my solution set is x such that x is going to be greater than, greater than 0. Is it equal to 0? No, because it's not in flight until it leaves his hand. So at time 0, it was in his hand. So I'm going to say x greater than 0, and x has to be, again, when it hits the ground, it's no longer in flight, and it hit the ground at 3.19 seconds. So I'm going to go less than 3.19 seconds. And x is an element of real numbers. And that's my answer. Now, we're going to check our work using technology here. So the first thing I'm going to do is cheat by going algebra and factor. And I'm going to type in my solution, or my quadratic. So negative 4.9, and I'm going to say x squared plus 15x plus 2. Now remember, if you just do this and find your x-intercepts, I am not going to allow that. You need to show your work. So then I have a 3.19 and a negative 0.12, which is 0.127. So this is exactly what I found using the quadratic equation. So perfect. So my quadratic equation was done correctly. Now what I'm also going to do is I'm going to graph. So let's go to our graph, and I'm going to now graph this. So negative 4.9x squared plus 15x plus 2. So there we go. And of course, it's positive above 0. And like I kind of thought, so I'm just going to zoom in a little bit. Like I kind of was doing in my head, it's not actually going to be leaving the hand until this point, right? Because this is 0 seconds and it's 2 meters above. And at all of these points, it's flying in the air. We can figure out the vertex graphically. There's the vertex. Happens 1.53 seconds later, and it goes to 13.5 meters. But like I said, I don't really need to know that, right? That's unnecessary information. What I do need to know is when it hits the ground, which is 3.19 seconds later. And so, you know, there we go. There's our answer. So we did it correctly. And even our little makeshift graph was actually pretty good. It was pretty accurate. All right. So there's that. Now it's going to be your turn. So your question says, a golfer hits a ball down a fairway. She would like to know the length of time in seconds that the ball was at a height of at least 25 meters. Ooh, that's a bit more challenging. Solving the inequality of that will help determine this. So go ahead and try this out. When you think you have the solution, come on back. All right, welcome back. So your inequality actually said it's 4 when it's more than 25. So you just have to find your X-intercepts here. So what you would do is first set it equal to 0. And once you've done this, you solve for your X-intercepts. So again, quadratic equations, probably the best method. Now what I did is I used the first method using test points. And so I have regions and test points. So I have this region, and this region. And then I found my test points. So I'm testing 0, 2, and 5. And I found that it's this region that's true when I do that. And so my answer becomes that region. So from 0.73 seconds to 4.27 seconds, elements of real numbers, and there we go. All right, so we probably also want to do this graphically, so let's go ahead and try that. So we have negative 8x squared plus 40x minus 25. So there's our quadratic. Now we know that this is a golfer, right? And we're looking at for the time in which it's more than 25. And so anything less than 25 is actually going to be below here. And so at 0 seconds, the height was actually 0, right? And it looks like from this point on, it was above 25. It was greater than 25. And so we just have to find our zeros, not our minimum. We want to find our zeros. And so this is at 0.73 seconds, it was above 25, and below less than 4.27. So in between those two, and that's the region that I found, and that is the solution I found. So there we go. That's how you solved your problem. You might have done different methodologies, but you should have come up with the same solution. All right, that's it for this unit. Thanks for watching. See you next time. Bye-bye. Hey everybody, you can like, follow, and subscribe to my social medias right here to get notifications as soon as new content is uploaded. This video concludes our learning unit. You can find the playlist this video was in right here and click here for the next unit that we'll be covering. Thanks for watching and keep learning, everybody. Bye-bye.